strain is equal to a constant. So it's equal to a constant. This constant can be denoted by any factor, and this constant we call it as the modulus of elasticity. We call it as the modulus of elasticity. So it means this statement for the Hooke's law. Hooke's law, it states that within the elastic limit, stress is directly proportional to strain. So therefore we have that stress by strain is equal to a constant, and this constant we call it as the modulus of elasticity. And when we speak of the modulus of elasticity, this constant modulus of elasticity, there are three types of the modulus of elasticity. So for the three types of modulus of elasticity, we have what we call as the Young's modulus, the modulus of rigidity, and also we have the bulk modulus. So number one, we have the Young's modulus. So these modulus, it means here we will see what are these modulus of elasticity. So number one, we will see for the Young's modulus, and Young's modulus here, it is denoted by Y. So for the Young's modulus, Young's modulus, that it is defined that within the elastic limit, this Young's modulus, it is defined as the ratio of longitudinal stress to longitudinal strain. It means it is defined as the ratio of longitudinal stress to longitudinal strain. So it means here we have that it is defined as the ratio of stress is to strain. So it means Young's modulus, it is denoted by Y. So how is it defined? It is defined that within the elastic limit, it is defined as the ratio of longitudinal stress to longitudinal strain. So now from here we see what is longitudinal stress. So earlier just now we have seen what is stress. Stress is equal to force per unit area. So therefore it is equal to F by A. And longitudinal strain. What is longitudinal strain? Longitudinal strain, it is defined as the ratio of change in length. Change in length, it is denoted by del L. To the original length, it is denoted by L. So therefore from here we have this is equal, transpose this to the numerator. This will give you as FL. This will give you as FL divided by A into del L. So this will give you as FL A by del L. So this will give you for the Young's modulus. So therefore we have that the Young's modulus is equal to Y is equal to F by A del L by L. So this is equal to FL A into del L. And again, here we say we take for the SI unit. The SI unit, here we take the SI unit of force and the FI unit of area. Since here we have this will give you in meter, this also will give you in meter. So meter gets cancelled. So therefore here we see that the SI unit of Young's modulus, it is equal, you take the SI unit of force, this will give you as Newton. SI unit of area, this will give you meter square. So this will give you as Newton per meter square. And this Newton per meter square, we call it as Pascal. This Newtons per meter square, we call it as Pascal. So therefore we see that the SI unit of the Young's modulus also is termed as Pascal. It means the SI unit of Young's modulus is the same as Newton per meter square. And this Newton per meter square, we call it as Pascal. So it means here we have the three definitions. What is the modulus of elasticity? Number one, modulus of elasticity, the Young's modulus, which is denoted by Y. Y we call it as longitudinal stress by longitudinal strain. So stress we know is equal to F by A, and strain is equal to del L by L. So therefore this will give you for the SI unit Newton per meter square, and Newton per meter square we call it as Pascal. So this will give you for de Young's modulus.